Okay, guys, I hope you're doing great. In this video, I'm going to talk about how to solve an equation using your calculator. In this case, I'm using TI-Nspire calculator. We're going to learn 3 methods. It's a very useful video for all the students of applications and interpretation, and also students of AA can learn from this video. So obviously, the very first method that we can use to solve equations is numerical solve. Numerical solve. So for example, let's go and solve this equation together. This one here. Example, 3x minus 7 equals to 3x minus 7 equals to 11. So all I have to do is to come here, menu. I'm going to go and choose add calculator. So menu 1, add calculator. Here, I'm going to go on menu. You're going to choose algebra, numerical solve. Algebra, numerical solve. Okay, and here you're going to type your equation as what it is on your paper. So 3x minus 7 equals to 11. Remember, what happens if I press enter? It's going to give me an error. Okay, why an error? Because question is asking you, a calculator is asking you for which variable you're solving this equation. So I want to go for comma x. I'm telling my calculator that please solve this equation here for x. My variable is x. Solve it for x. Press enter. The answer is 6. Okay, so when you have any equation, you're going to copy and paste into this bracket, numerical solve equation, comma x. Instead of x, if you have c, you're going to put comma c. If it's k, comma k. Okay, that's it. Let's do one more just to practice. So this time, instead of going through the menu, I can type also, why not, numerical solve, and 3 times 2 to the power of x equals to minus 5x minus plus 1 comma x. Again, the answer is minus 0.29. Okay, that's it. So I think there is no question here. There is a problem with numerical solve. So in many questions, especially if you have some simple calculations and you know that you have only one answer, numerical solve is the best way to solve the equation. But in what if you have an equation like x to the power of 2 minus 3x plus 2? So look at this equation. Okay, this equation has two solutions, x equals to minus 1 and x equals to minus 2. Okay, minus and 1 and minus 2, they are both the solutions are, pardon me, 1 and 2. They are both the solutions of this equation. Okay, 1 and 2. Now, I'm going to go and put this equation into the calculator. So with numerical solve. Numerical solve. So x to the power of 2 minus 3x plus 2 equals to 0, comma x. When I press enter, what happens? It only gives me one of these solutions. One of these solutions, okay? So I'm missing one of my answers. So if you have more than one solution, unfortunately, numerical solve is not going to give you that answer, okay? So what if we have more than one solution? Okay, the solution in this case is either you can use polyRoots or you're going to go for graphing method. Okay, polyRoots. Let's talk about polyRoots. What is polyRoots? So let's look at the equation we have here. X to the power of 2 minus 3x plus 2 equals to 0. I'm going to use this with polyRoots. So menu, you're going to go for algebra, polynomial. Let me do it one more time. Polynomial tools. You're going to go for real roots of polynomial. Real roots of polynomial. We're going to find the real solutions. Okay, in your course, I'm talking about application and interpretation, standard level. Okay, so you're going to copy and paste your equation. Polyroots x to the power of 2 minus 3x plus 2, comma, okay. Here you don't need to put equal to 0. You don't need to put equal to 0. You don't need to put that, okay? Comma, 0, comma, x. Now you have the two solutions, okay? 1 and 2, okay? Remember, for polyroots, you don't need to put equation one more time, okay? So what are the conditions to use polyroots, or what you see here? Okay, first, you have to put whatever you have on one side. So something equals to 0. So for example, you cannot solve this with polyroots. You cannot solve this directly with polyroots. You have to put -2 to the other side. So you have to say x to the power of 2 minus 3x plus 2 equals to 0. This is the first condition. The second condition is that this term, as you can see, polyroots, it has to be a polynomial function. What is a polynomial function or polynomial expression? An expression in this form, ax to the power of n plus another coefficient, x to the power of n minus 1, up until a constant a dot, okay, a0. What does it mean? For example, x to the power of 4 plus 3x to the power of 2 plus 0x to the power of 1 minus 1, okay? This is a polynomial expression, okay? So x to the power of a natural number, okay? So for example, you cannot use it for x to the power of -1, okay? Let's just try it here together. If I put x to the power of -2, it's not going to accept it as a right expression, okay? So let's recap it. You can use polyroots only if you have polynomial expression equals to 0, okay? That's it. Okay, now let's just solve this example that we have here. -6x to the power of 2 plus 11x minus 6. Press enter. You have three solutions, 1, 2, and 3. X equals to 1 is one solution. X equals to 2 is another solution, and x equals to 3 is the third solution. Now, polyroots is very helpful, but what if your equation is not in the form of polynomial expression? So what is the solution, for example, for this equation here? You see that this side is polynomial expression, but this is not a polynomial expression, okay? So how can I solve this kind of equations? We're going to learn graphing methods, which is the best and always helpful method to solve any equation, okay? So how to use graphing method? You're going to go and graph the left side, then you're going to go and graph the right side. You're going to find the intersection points. The x values of the intersection points are your solutions of the equation. What does it mean? Let's do it together. Control I. I'm going to open a new tab, okay? Control I. Now, I'm going to go for add graphs. Here, I'm going to graph the left side. What is the left side? 3x to the power of 3 minus 2x to the power of 2 minus 1. So this is the graph of the left side. Now I'm going to go and graph the right side. Menu, graph, function. E to the power of x. Remember, you have to choose this option here. E to the power of x minus 2.22. Press enter. Okay, now you see that you have two graphs, the red and the blue one. Do you agree with me? These graphs, they have three intersection points. Let's go and zoom in a little windows. Let's go and zoom in. 1, 2. Okay, we're going to find these intersection points together. How? Okay, well, I have three intersection points. I'm going to find the intersection points. First, analyze graph, intersection. This is the first intersection, 1 point, 15. So one of the solutions, don't look at the y value, look at the x value here. It's one solution is x equals to 1.15. This is the first solution. What about the second solution? Menu, one more time, analyze graph, intersection. This is the second solution, x equals to 0.165. Again, don't look at the y value, menu, analyze graph, intersection, minus 0. The third solution is minus 0.415. You have three solutions for this equation, and we found the solutions with the graphing method. Okay, that is all about this video. I hope it was helpful for you. Let me just have a quick recap. So we learned about numerical solve. The problem is that it gives you only one solution. It's very helpful if you know that you have exactly one solution. If you have a first grade equation, use this method. Okay. Polyroots is very helpful for polynomials only. Equation must be equal to 0. And the graphing method works for everything. X value of the intersection points, if there is any. Sometimes there is no intersection point, no solution. Okay, and there are going to be the answers. Thank you so much for watching this video.